So we have seen that how a strong compiler can be used for avoiding a data hazard. In the same way, we have a hardware solution also. Now let's come to the point of hardware solution. You see, to realize this hardware solution, the firstly you have to realize that the structure of the pipelining and where it is having the problem. So if we draw the stages, the processor in form of connection of the stages, fetch, decode, execute, and write back. Now you see that we had a situation something like this. The instructions, let's write the instructions here again. I1 is add B and I2 is add C. So that means somehow we have seen that when this add B is fetched, then decode, then execute, after execution complete, the result accumulator is actually on this data bus. If I consider this is a data bus which is carrying the input from output of the execution unit to the input to write back unit, so that it is written back in the memory, that means we can assume that this is basically a data bus representing. So after adding the accumulator content and content of B, before the updation of the accumulator again, the result is at least valid in this particular data line. Now problem is that since the next instruction again require the accumulator content, that is why until this write back completes, then only you cannot use this one in the input of execution, because before input of the execution of the next instruction at C, I must require the new value of the accumulator. Now to avoid this, what actually we can do, we can say that before, in this especially in this type of situation, when the next instruction also requires the current value of the result of the previous instruction, then one thing we can say that I can consider here a feedback path, a feedback path in this direction that will be input to the execution unit itself. If I have a something like this, then what will happen? When execution completes for the first instruction and result is available on this data line, and if the second instruction require the data result from the previous instruction, then this feedback line can be used to carry the updated result to the input of the execution unit. So that the next instruction doesn't need to wait this particular in, I mean, it doesn't need to wait for the output, I mean, for the updated result, so that the execution unit holds for some time. It doesn't require, right? Now, question is that every time this particular, it's not, I mean, it's not true that every time you will have some dependency. right? For example, we have seen that if we have two instructions something like a equal to b plus c and x equal to y plus z, then there is no dependence. In that case, this feedback line is of no use. First point. Second point is that how a processor will realize that this input of the execution will be taken from decode output of the execution output. In which one? I mean, for this type of case, the execution unit should take output from previous stage. But in case of this type of case, the execution unit should take output from the output of the execution unit itself. So there are two possibilities, but either from this path or from this path, not from both, right? So that means somehow we have to choose one of them. Depends on the situation, depends on the actually you can say depends uh, on the code or the instruction. Now how we can do this? You see, here we can use a very interesting digital circuit. Uh, we have seen, we have many times we have used that. That is what we call multiplexer. What a multiplexer does? Selects or choose one line from 2 to the power n line, right? Here this 2 to the power n line is what? One from decode output and one from execution output itself. So here it is two line, and naturally I need some select line. So how the select line will be connected, that I will come later. But with respect to the this type of diagram, if I say what the modification will be in between decode and execution stage. And how it can happen? I can say that I have a fetch stage, then a decode stage, then I will put a multiplexer. And that multiplexer output will be on the execution stage. And then the output of execution unit will go to the write back stage. As simple as that. But what is the input of this? One input will come from here, and another input will actually come from this one. I'm sorry. Oh, not this one. I should say it's actually coming from this part here, right? Something like this. Depends upon the type of instruction or the dependency upon the instructions. Either the data will be taken from this one or this one. Now question is that with respect to the original hardware design, if I try to imagine that where the modification will be done, we realize one thing, try to understand one thing, that this unit is executing, and a very important component of this execution unit is ALU, because ultimately all the logical and arithmetic operations are done by the ALU. So the input to the execution unit that we are talking about is basically, you can say, a sort of input to the ALU. So that means this multiplexer must be present before the input of ALU. That's for true. That's for sure. So if we try to understand this diagram, the modification, what we can do in this diagram, you will see that we can modify it actually over here, for example, or maybe here. It depends upon from where the data comes, and that's decided by some hardware and software. So I'm not going in detail of them, because the instructions are also very intelligent. The addressing modes and all, the instruction design is itself very intelligent, so that it can be expressed in that way. But one thing is sure, that we must have some multiplexer over here. And if I just let's draw correctly this line. I'm sorry. Okay, it's not possible to remove this. So what we can do, we can draw a multiplexer over here. So there are two different ways, because you don't know in which path it will come. So that means, and the another input of this multiplexer will be one from here and one from another part, that is this one. And this is my data line where the data is coming. So now naturally will question come that then how the select line will be there. We can, what we can do, we can keep a common select line for them, which is connected with the timing and control unit. So because this is the brain of the whole processor, which will decide that whether the selection line will be 1 or 0. Based on that, the data ALU will take data either from the accumulator or data register, or from the ALU output itself, which is available on the data line after executing some instruction. So this is what we have discussed is the hardware solution, and the approach actually what we are doing, you are actually the operand that you require in the next instruction. Like if we consider this case, here it is a equal to a plus c, right? A is the accumulator, right? And here a equal, a equal to a plus b, and here a equal to a plus c. So what I require this a for using over here. And what is this? This is an operand, right? I'm sorry, this is an operand, right? Which is operated with some instruction, with some particular mathematical or logical operation. So this is what the approach that we have discussed over here is what we call operator forwarding. Sorry. this is what we call operator forwarding. So that means the solution of the data hazard we have discussed from two different perspectives. One from the software side, which require a strong compiler so that it can decide understand the hazard and somehow enter some NOP instruction within your instruction, right? So that the stages cannot take any wrong value. And in case of hardware solution, we have seen that we can design a little bit stronger hardware which can detect the hazard, and depends on that it can take data either from the previous units or from the output of the execution unit itself through the use of a multiplexer. So these are the two different approach by which we can overcome the data hazard. Now in the next day we will look upon the instruction hazard the control hazard in more detail, and we will see that what are the different type of control hazard we can have, and how we can again get a solution from those problems that can arise due to the unavailability of instruction. Thank you.